For number 3, we're asked to find the intervals where the function f is increasing and where it is decreasing and any relative extrema. So the first thing we're going to do, since we're looking for increasing and decreasing, we're going to find the first derivative. We're going to use the power rule. 3 times 1/3 would be 1. Reduce the power by 1, so that's 1x squared. The derivative of the second term would be minus 2x. The derivative of the third term would be plus 1, and the derivative of negative 6 would be 0. I'm going to get rid of the 1 that's out front. We don't need that. And we're looking for two things. We're looking for where the first derivative is 0, or where the first derivative would come back undefined. Since there are no denominators that have a variable, then we can ignore looking for where the first derivative is undefined, and we will take the first derivative and set it equal to 0. We're looking for x values that have a horizontal tangent line. So factor this, we get x minus 1 times x minus 1. And setting each factor equal to 0, we can tell that we're going to get the same solution for both. We're going to get x equals 1. So remember that this is a potential relative max or relative min. So we have one value, one x value that will separate our intervals. We have x equals 0. Sorry, x equals 1. So we found that x equals 1 could be the place where the increasing and decreasing intervals will change on either side of 1. So let's look and see what is the first derivative to the left of 1. Choose any value that you want. I'm going to choose 0. So we're going to plug 0 into the first derivative. 0 squared minus 2 times 0 plus 1, we get 1. Since this is positive, this represents a positive slope, and the graph is increasing from left to right. And then on the right, we'll choose any value that we want. I'm going to choose 2. So we're going to find out what is the derivative, the first derivative at 2. So we'll plug it in our derivative, so that's 2 squared minus 2 times 2 plus 1. We get 4 minus 4 plus 1. The derivative here is 1 as well. So this is a positive slope again. So we are also increasing to the right of 1. So the intervals for which we are increasing would be to the left of 1 and also to the right of 1. Since x equals 1 is included in the domain, there's not an asymptote there, then we could just express this answer in one of two ways. So either one will be fine with me for our purposes. You could say that you are increasing from negative infinity to 1, and then again from 1 to infinity. Or, since 1 is in the domain of the function, you could say that it was actually increasing for all real numbers. So either one of those solutions will be fine with me. So you can say this, or you can say this. Both of them will be countercorrect on the exam. We are not decreasing for any intervals, so we'll say none. And do we have a relative max or relative min? Since the function does not change, does not switch from increasing to decreasing or decreasing to increasing, then there is no relative max or relative min. So there's no relative extrema here. For number 4, we're also asked to find out where the function is increasing or decreasing in any relative max and relative mins. So before we find the first derivative, which we know we want to find that, let's rewrite the original function. We're going to write this as x plus 4, and we're going to bring this x to the top of that fraction. We're going to write this as 4 times x to the negative 1 power. Now we can use our derivative rule really easily. So the derivative of x would be 1. And then for the second term, we would get negative 1 times 4, so it's negative 4x, and then reduce the power by 1. And I'm going to rewrite the first derivative with only positive exponents. So I'm going to bring that x squared back down to the bottom of the fraction. Now we're going to be looking for two things. We're going to be looking for where the first derivative is 0, or where the first derivative might come back undefined. So let's set our first derivative equal to 0. Alright, I'm going to bring this fraction over to the right-hand side, so that gives us 1 equals positive, now 4 divided by x squared. And then we're going to make each side look like a fraction and then cross multiply. So that gives us 4 equals x squared. We're going to take the square root of both sides, and we get plus or minus 2 is equal to x. So we have two places where the graph has a horizontal tangent line. So remember, these are potential relative maxes and mins. Then we also have a place where the first derivative would come back undefined. If we take that denominator of x squared and set it equal to 0, we would see that x equals 0 would cause our first derivative to become undefined. So we actually have three values that will separate our number line. We have minus 2, we have 0, and then we also have positive 2. Okay, so we're going to choose some test intervals here. To the left of negative 2, we'll choose negative 3, so we'll choose that as our test value. We're going to plug that into our first derivative. And that will be 1 minus 4 times negative 3 squared. Get 1 minus 4 ninths, and that would be 9 divided by 9 minus 4 ninths, which gives us 5 ninths. So this comes back positive, which tells us that the graph is increasing from left to right as we approach negative 2. Alright, let's choose something in between negative 2 and 0. I'm going to choose negative 1. F of negative 1. F prime of negative 1, rather, putting it into the first derivative. So we get 1 minus 4 over negative 1 squared. Simplify, we get 1 minus 4 over positive 1, which is just 1 minus 4, we get negative 3. So the slope here is negative, and since we have a negative slope, we know we're decreasing in between negative 2 and 0. Okay, and to the right of 0, I'm going to choose positive 1. Okay, so I'm going to put a positive 1 in to my first derivative, and then we're going to simplify. This is very similar to putting in a negative 1. We get 1 minus 4 over 1, which is really just 1 minus 4, which gives us negative 3. So the slope is negative, so it tells us once again we're decreasing from left to right in between 0 and 2. Lastly, we'll choose a value to the right of 2. I'm going to choose 3. We're going to plug that into our first derivative. And this, once again, will be very similar to the value we got for negative 3. That's 1 minus 4 ninths, and we already know that that's going to equal 5 ninths, which gives us something positive. So we have a positive slope from 2 to infinity, so we're increasing there. Alright, so the intervals for which we are increasing would be from negative infinity to negative 2, and then again from 2 to infinity. And we are decreasing rather, from negative 2 to 0, and then again from 0 to 2. Now we cannot lump those together actually into the same interval, because at x equals 0, if we look at the original function, x equals 0 would cause the original function to become undefined. At x equals 0, there would be an asymptote there. And since there's an asymptote there, we can't actually include 0 as part of our intervals for which we are decreasing. So these must be in two separate intervals. Now, the last thing we want to look at is, do we have a relative max or a relative min? So we do have a relative max here at -2. And we'll find the y value, make sure it's in the domain of the function. And do we have a relative minimum? And it looks like we do here at +2. So we decrease and then we come to the bottom and then we start to increase after that. So we're going to say 2 would be a relative minimum. Now let's find the actual values in the function, on the function of f. Let's find the y values for each of those points. So we'll plug in a -2 into the original function. So it'd be -2 plus 4 over -2. We get -2, then of course this is -2, so we end up with -4. So if -2 goes in, -4 comes out. And let's find the y value for x equals +2. That would be 2 plus 4 divided by 2. So that's 2 plus 2, which gives us +4. So these are the points at which the relative max and relative min would occur.